Welcome to the Meteorite Hunting Program. Today, you and I will go into an area with a lot of rocks. Practice meteorite identification exercises to choose the rocks that are most likely to be meteorites. Now, let's get started. I saw a piece of rock with many dark brown spots, possibly pyroxene and rust stains. After observing it carefully, I immediately realized that it was a type of gabbro rock, which has a density of about 3 grams per cubic centimeter, so I didn't pick it up. This is a basalt stone. It contains a lot of iron, so the outer layer has turned brown. Oh, here it is, a rather large buried stone. It looks very much like a meteorite. The color of this fracture is very familiar. It is a porous type. It is scoria stone. This piece of breccia looks like the crust of a lunar meteorite I saw somewhere, but on closer inspection I see it contains many quartz fragments. I picked up this piece. It was grey and contained white fragments. It looked a lot like a lunar meteorite. It was very small, so it was very collectible. Adding a piece with a very suspicious outer shell, I applied the simple quartz test. This piece of rock has a lot of rust, a lot of pyroxene and plagioclase grains. I saw a bit of luck. It seemed heavier than other stones of the same size. That was a very happy sign. This is gabbro. It's different from the previous one, but I see this type of rock a lot in volcanic areas like this. An olivine basalt with a weathered outer shell, very similar to the crust of a meteorite. I picked up this piece because the mineral looked very similar to enstantite. A heavily weathered piece of basalt, which internally resembles a carbonaceous chondrite meteorite. I broke it open to see if it contained the necessary minerals. It was just weathered basalt. This is the sound emitted by stones containing a large amount of quartz. Many of the breccias contain quartz fragments with a white crust, which reminds me of a lunar meteorite with a similar crust. This is also a basalt stone with a rusty crust. This reddish-brown crusted stone cheered me up a bit. There were black streaks. I thought it was the burnt crust left over. I decided to pick this piece up. This piece contains some olivine, but its specific gravity is around 2.7 to 2.8, so I didn't choose it. This piece is quite heavy. I guess its specific gravity is around 3.5. Lots of rust, lots of black pyroxene particles, and lots of shiny metal particles. This piece is also quite heavy. It contains a large percentage of minerals to be studied. I picked up this piece as well. I gathered all the stones I had picked up from the stream. It was already afternoon. Yesterday, I picked up a total of 6 stones. There are only 3 here. Now I will take them to cut. I use 3 polishing pads, 100, 200 and 300, wet polishing. I continue to use a dry polisher, using sandpaper. Because there are types of stone that are heavily weathered, wet polishing is not possible. This small stone, after it dried, I saw that it had quartz in it, so I didn't cut it. The largest piece, which has a few black streaks, is also quartz containing breccia, so I didn't polish that slice. The rock matrix has many shock marks. Most of the minerals inside are white. I think it is enstantite. It could be an angrite meteorite. The mineral grains in this fragment are relatively large, and it has a meteorite-like structure. It could be an angrite meteorite, or it could be a Martian meteorite. This piece also contains instantite-like minerals, but is less likely to be a meteorite than the other two. This piece has a large amount of white plagioclase and pyroxene with some metal. I can see it very clearly, so I did not cut it. It could be a eucrite meteorite. I will send all 4 pieces for XRF analysis the day after tomorrow. When I have enough information, I will send them for classification. Thank you for spending your precious time watching the entire video. Please like and subscribe to support our channel. Goodbye. See you in the next video.